Hi, my dear students. Welcome to India's biggest online platform, Manifold Institute GATE classes. Today, we are going to discuss a very interesting topic, hydrostatic forces on surfaces. In this session, we can discuss some problems based on hydrostatic forces on surfaces. Let's start the session. Read the question carefully. A hinged gate of length 5 meter inclined at 30 degrees with the horizontal and with water mass on its left. That means water present at left to the inclined gate. Okay, as shown in the figure. Density of water is given as 1000 kg per meter cube. The minimum mass of the gate in kg per unit width. Width is measured perpendicular to plane of paper. Required to keep it closed is, okay, to make the inclined gate is closed. Okay, so what is the mass of the gate we need to maintain? That we need to determine. Mass of the gate in terms of kg we need to determine. Let's solve this problem. Read, see the figure here. Inclined gate, it makes an angle 30 degrees with the horizontal. Just give projection vertically upward direction. Okay, so once you see the gate, okay, from side view, you can see the width of the gate. Width of the gate is W and length of the gate is 5 meter. Here width of the gate is B. Okay, so now see here, G is center of gravity of inclined gate, P is the center of pressure. Here, first we need to determine the magnitude of hydrostatic pressure force acting on inclined gate. After that, location of hydrostatic pressure force, that is H star, we need to determine. After that, you can draw free body diagram for inclined gate, then you can apply equilibrium equations to determine mass of the gate. Okay, see here, weight always act vertically downward direction. As a first step, we need to determine hydrostatic pressure force acting on inclined gate. That is Fp. Okay, so Fp star we need to determine. Fp star. What is the magnitude of Fp star? See here, Fp star equals to rho g into Ah bar. Rho g into Ah bar. Here H bar is the distance between, okay, so free surface and center of gravity of the inclined gate. Okay, so here H bar is nothing but, so how to determine H bar? Inclined length will be 2.5 meter. So here 30 degrees. Once you construct a triangle, this is equal to 30 degrees, then you will be getting H bar equals to 2.5 meter, 2.5 sine 30 degrees. So here H bar equals to 1.25 meter. What is the area of the gate? What is the area of the gate? Inclined gate, that is nothing but width into length of the gate. That means 5b meter square. 5b meter square. Next, rho is nothing but density of the water present left to the inclined gate. Here we can say that this will be 10 cube kg per meter cube into 9.81 meter per second square. Area is nothing but 5 times b meter square into H bar is nothing but 1.25 meter. Now tell me, what is the magnitude of hydrostatic pressure force? Fp star equal to dash Newton. Calculate and tell me. Here you will be getting 10 cube into 9.81, 5 into 1.25. Finally, we'll be getting 61,313. Okay, 61 313. 61, 312.5 B. 0.5 B. In terms of width of the gate, you will be getting. Here finally, FP star equivalents to 61. See here, 61, 312.5 B Newton. Okay, so in terms of Newton. Now we need to determine the location of the hydrostatic pressure force. Okay, center of pressure we need to determine. How to determine the location of center of pressure? H star. As we know, H star is nothing but H bar plus IgG by AH bar. AH bar sine square theta. Here theta is nothing but 30 degrees. IgG equals to B times 5 cube by 12. B times 5 cube by 12. Finally, H bar is nothing but 1.25 meter plus B 5 cube by 12. 5 cube by 12 by area is nothing but 5 times B into H bar 1.25 meter into sine square 30 degrees. Sine square 30 degrees. Finally, what is the magnitude of H star? Dash meter. Calculate and tell me. Now, what is the magnitude of H star? See here. Calculate. B and B gets cancelled out. Okay. 5 cube by 12. 5 cube by 12 into 1 by 4. Okay. Sine 30, 1 by 2. 1 by 4 by 5 by 1.25. Okay. 0.4166 you will be getting. 0.4166 plus 1.25. So finally, what you will get? 1.667. Okay. So H star is nothing but 1.667 meter. Okay. So you located hydrostatic pressure force. Okay. Hydrostatic pressure force is acting at a distance H star from the free surface. Okay. Now we need to determine, we need to draw free body diagram for inclined gate. Weight always act vertically downward direction. Weight of the gate is acting at center of gravity, and hydrostatic pressure force is acting at center of pressure. To apply the moments about the hinge O, you need to know this particular distance. We can say it is OMG. From this triangle, we need to determine GM because we need to apply moment about O. Moment of W about point O, hinge O, is nothing but W into GM. How to determine the magnitude of GM from this particular triangle? Okay, so here O, this is G, O, M and G. It is 30 degrees. 30 degrees. From here, what is this? 2.5 meter. Here 2.5 meter. And we need to determine mg. And H star, H bar we know. H bar is how much? 1.25 meter. 1.25 meter. You can apply cos theta or tan theta. That is up to you. What is cos theta from here? Cos 30 degrees. From triangle OMG, cos 30 is nothing but mg by 2.5 meter. From here, what is mg? Mg equals to 2.5 into cos 30. Here 2.165 will be getting. Okay, so 2.165 meter. Okay, so if you want to apply tan 30, how much you will be getting? Tan 30 is nothing but 1.25 by mg. 1.25 by mg. 1.25 divided by tan 30. That is also 2.165. Here mg, you got it, mg. It is very important to apply moment. Mg is nothing but 2.165 meter. Okay, one more distance we need to determine, that is OP. Okay, to moment of FP star about hinge point O is nothing but FP star into OP. How to determine OP from the triangle? Here, this is NONP. ONP. So from this particular triangle, ONP. ONP. Here ON is nothing but H star. This is H star. Okay, what is H star? Just now we determined H star. What is H star? Tell me. 1.667. Okay, so from here we are having H star is nothing but 1.667 meter. So we need to determine, this is 30 degrees. How to get OP from this particular triangle? Tell me. Just apply sine 30 degrees. Sine 30 degrees equals to H star by OP. OP equals to H star by sine 30. H star by sine 30. 1.667 by sine 30. Sine 30 is nothing but 3.334. So here OP equals to 3.334 meter. Now we can apply moment about the hinge O. Moment about the hinge O. Okay. So once you apply the moment, sigma m about point O equals to 0. Once you apply it, what you people will get? Tell me. Moment of W about point O. Is it clockwise or anti-clockwise? Clockwise direction. Moment of hydrostatic pressure force about point O. Anti-clockwise direction. Sum of the clockwise couples equal to sum of the anti-clockwise couples. Now tell me what you will get. W into okay, so mg. W into mg will be getting FP star into how much you will be getting? FP star into OP. That is anti-clockwise direction. OP. So now I can say that W is nothing but m into g. Mg is, what is the distance? Mg 2.165 meter. 2.165 meter equals to FP star into OP. How much is OP? 3.334 meter. Finally, what is the value of M? Mass of the gate. We need to determine mass of the gate. M equals to FP star into 3.334 by, okay, G into 2.165. 2.165. Just now we determined the magnitude of hydrostatic pressure force acting on inclined plane. Inclined gate. What is that? Tell me. What is FP star? FP star, tell me. 61312.5. 61312.5. 61312.5. 61312.5 B into 3.334 by 9.81 into 2.165. 2.165. What is the value of mass of the gate? Tell me. 2.165. Okay, so calculate and tell me. 61312.5 into 3.334 divided by 9.81 divided by 2.165. 2.165. Finally, 9624.711. Here M equals to 9624.711. 711B. They have given per unit width of the gate. If you consider B equal to 1 unit, okay, so mass of the gate per unit width, mass of the gate per unit width, 1 unit, then mass of the gate M equals to finally 9624.711 kg you will be getting. Finally, what is the answer? Tell me. M equals to 9624.711 kg. Okay, so this is the answer. Final answer. What is the mass of the gate we need to maintain to close the gate? Okay, in order to close the gate. Clear na? So this is the mass of the gate. M equal to 9623 kg. M equals to how much you are getting? M equals to 9624.711 kg. This is the answer. Okay. M equals to, so close answer will be thus 9623 kg. This question given in GATE 2013 by IIT Bombay.